For problem number 3, we hope that the left side factors, and let's see, most likely the factors for the first term would be 2x and 2x, but it doesn't look like that's actually going to work. So if I put a 5 here and a 1 there, then we're going to have 10 and 2, so that's not going to work. So the next and only other option would be for the first to be 4x and the other first to be an x. 4x times x, 4x squared. And then if I put a 5 there, I'm going to get a 20x if I multiply the outside. So I got to put the 5 there and the 1 there. So factors of 5 are 5 and 1. Factors of 4x squared are 4x and x. So I get a 4x and a 5x. And if my 5x is negative, then I get a negative x. So those are my factors, and when I set the factors equal to 0, we get first factor equals 0, means that x is equal to 5 over 4, and the second factor, if it equals 0, it would only equal 0 if x is negative 1. So those are the two solutions to that algebraic equation. So that's quadratic equation, and then we're studying those because we are also then going to use the same process when we solve trigonometric equations when they end up being quadratic, but with a trigonometric function in place of x. So I think what I'll do here is I'll just keep going here until I hit about the 5-minute mark. So for number 12, in solving this equation, we want to isolate the cosine of theta. So we're going to go ahead and subtract 1 from both sides. We could have added cosine to both sides if we wanted to. That probably would have been better. Negative cosine theta equals 1/2 minus 1 is negative 1/2. So what we're looking for is all the values of theta in which the cosine of theta, so divide both sides by negative 1, where the cosine of theta is equal to 1/2. And we know that the cosine is positive in the first and the fourth quadrants. And we're looking for the solutions to this equation on the interval from 0 to 2 pi. And the cosine is 1/2 right up here at the top. That's the pi over 3 angle, as well as right down here on the bottom, the angles closest to the y-axis in the first and fourth quadrants. So therefore, since the cosine of these two angles is equal to 1/2, then we say that the solution on the interval from 0 to 2 pi is the angle 5 pi over 3 as well as the angle 5 pi over 3. There you go. I think this next one might take a little bit longer, so I'll do that one in the next video.